On today's SuperHigh tutorial, what we're going to be talking about are water effects. So how do we make something that looks like this within a web browser? So just to give you some context where this idea has come from, one of our students, Rafi, posted this in the SuperHigh student Slack and said, how would we do this in the browser? Now this is just a GIF. This could be made in an image program. It could be made in After Effects, for instance. What we want to do is make something for the web based on an image. So this is the image that we're going to be using. How do we alter and change this in real time? So what we're going to be using for this is a shader. Now we're going to be doing this tutorial in two halves. The first half is we're going to be using this in a kind of like a prototyping tool called KodeLife. In here we have this GPU shader editor. We're going to be working inside of this to actually build out what it looks like. And then the second half is we'll take the code that we wrote in KodeLife and move it onto the web. So what do we need to do this? Well, you could use KodeLife. You could just go straight into the web as well if you wanted to. KodeLife is free. You can get it from hexel.net/KodeLife. It's a really great program. I use it all the time. So what we're going to be using is KodeLife. We'll write our shader, make something that looks like this within a non-browser setting, and then we'll move it into a browser setting. So the first thing that I've done is I've gone to KodeLife and I've downloaded the app and I've just opened it up in the background. So here, if you're not seeing exactly this, you could go to File and New and it should look something a little bit like that. Now, what we're going to start with is basically adding this image into the project. So at the moment, I've just added my image to the desktop, jellyfish.jpg. Just going to pull this into my project. Now, what I want to do is basically make my output the same as this image right now. And at the moment, we're getting something that's a demo. Now, the first thing I'm going to do is change the resolution here just to be the same size as the image. So this is 1200 by 1200. If your image is a different size, then obviously you can change that resolution too. Now, what we want to do is get rid of this default and instead have this image being in this place. So the first thing we're going to do is get rid of this demo. Now, essentially there's two parts of this. The first one is where we are in our coordinate system. And the second part is what color that should be. So at the moment, all of this code in here is just having this demo that gives us this kind of pattern. So what I want to do just to start with is replace this with a solid color. Now, this vec4 is a color. It's a red, green, blue, and alpha part. So if I start changing some of this and say this first part is just going to be a solid red color, and this is 1.0, maybe the second part is going to be 0.5, and then this last part is going to be 0.2. This gives us a orange texture. And if I change some of these numbers, of course, if I change the blue and increase this, it starts to add more blue to this. So I'm getting this magenta color. Now, of course, what we want to do is not have this color set in stone. We want to base it on this image itself. So how do I get this? Well, this image that I just added has given a variable by default as texture4. Now, if I replace this with texture4 with just image down here, just so I know which thing I'm talking about, what I want to do is use this in my code. So at the moment, I've got this texture 0, texture 1, texture 2, texture 3, all of these different samplers. I'm going to get rid of all of them but one and replace this first one with image. So I've got this uniform. Uniform is things that get passed into this program, such as an image. What we want to do with this, we want to sample this image. And what is this thing called? We called it image. So now what we can do is grab this image and basically sample parts of this texture. So to do this, between my UV and my frag color, I'm going to say a vec4 of color. And this is going to be the final color. What we could do is just say vec4, and this is going to be a solid red, no green, no blue, and full alpha channel. So this should give us a red color. Now we're not using this color at the moment. Let's replace this vec4 here with color. So now I've just basically replaced what I had from before with a variable. But what I want is this color to be dependent on this texture. So what I'm going to do instead of this color is replace it with texture 2D, and in round brackets, the thing that I want to sample, which is called image, and then where I want to sample it, comma, UV, and in round brackets. Now UV is basically the texture's coordinates we can see up here, and this is vec2, the X and the Y direction going across and up and down. And by default, what KodeLife does is say, I want this to be in the middle 0, 0, and then this to be 1, 1, and this is -1, -1. Now we don't want to do this. We actually want to just say -1, not -1, 0 to 1 on all sides because we're sampling this texture. Now what we can do is remove this first bit here, this -1 plus 2 to reset the coordinates. If I do this, what we should see is this being the right way. Now, one thing you might notice if you're using KodeLife is this image might seem upside down. Don't worry about this for now. When we go to the web, it will be the right way up. If you do want to fix it, the quick way to do this is uv.y is equal to 1 minus uv.y. This will turn it upside down. Now, this will turn itself back the right way when we go to the web. So if you want to just uncomment this will just flip it around. Now, one thing to notice here is what we're doing when we do this thing here is we're sampling the coordinates at different places. Here, what is being passed in has been turned around. Now, I can do multiple things to this UV, such as shift it in all different directions. So for instance, I could say UV, I could say times equal 2.0, and this will just times it by 2 in all directions. Maybe I'll do 3 or 4 or 5, and it changes to be even smaller. I could do things based on things like time as well. I could add 5 and this just shifts it off the page. So maybe I'll do 0.5. You see there, it's shifted it up and across. Maybe I want to do negative way, so it's the other way. And maybe what I could do is say, well, this is just set in stone. But what I could say here is something like sine, round brackets, time. And this will just shift it in this kind of direction. So we're having this kind of wave appearing now. Now, what we have is a wave. We're using a sine wave with time to shift the coordinates around. And every time we shift the coordinates around, we're sampling different parts of this texture. So this is kind of what we're trying to do in the final part. We're moving our texture around based on the coordinates. So let's think about how water works. So I'm going to go to the browser. So what we want to do is this kind of effect. So when we look through water, we're seeing different parts of the pencil here. And this effect is called refraction. Now, you might remember this from high school physics. When we have some ray of light coming in, when it hits a boundary, it'll change direction as this slows down because glass is thicker than air. And what we get is this kind of wave of light looking different. Now, luckily, we can use this within our code. Actually, GLSL, the shader language, has refraction built in. So instead of this sine wave going in here, we can actually replace it with a refraction. So we're going to say, instead of this, refract. And in round brackets, what do we want to put in here? Currently, we're getting an error because there needs to be more than just refract in here. So let's go and look. So I, N, and eta. What do these mean? Well, here it says I specifies the incident vector. N specifies the normal vector. Eta specifies the ratio of indices of refraction. Now, if you've never done coding before, this sounds incredibly complex. And even with this, if you have done coding before, this sounds incredibly complex too. But let's break that down a little bit. So essentially what we're doing here, back on here, is we have a vector that comes in, which is the incident vector. Now this gives us a direction. And essentially this is kind of what we were looking at. So our incident vector for what we're doing here is we want to look at it straight on. So basically there's no shift across and there's no shift up and down. So the first thing that goes into our code, the vector, the incident vector, is we're looking at things straight on. We're going to use vec2 and in round brackets 0, 0, because we're looking at this straight on. Now the second one is all about the normal vector. Basically what this means is the surface. What is the surface going to look like? Well, this will depend because what we're going to have is a wave. So I'm going to start shifting this around in different ways. So we're not going to have this flat line. So for now, I'm just going to put in a comma and vec2 and in round brackets, just a small vector, something like 0.1, 0.1. And then the third thing that we put in here is a ratio of indices of refraction, which sounds again very, very complex. But essentially, what is the difference between air and glass, or air and water, or water and glass, for instance? Now we can go and get this and we can just try different numbers out, but we can actually go and get these numbers from Wikipedia. And we can see, if we scroll down, we can see there's things like, where is it? I've gone too far. Water. And water has a refraction index of 1.333. Now, we need to do the opposite of this because we're going from air into water. So what we're going to say for the last one is comma 1.0 divided by 1.333. So essentially, this is the kind of how different air and water are looking. So we're going to make this more physically accurate. We're not just typing in numbers in here. And what this will do is have a very slight shift. If I start changing some of these numbers, you'll start to see it shifting around. So essentially what we've done here is we said, if we're looking at this surface and the water is at a certain direction, this is the image that we'll see. But obviously what we'll get on this bit particularly is this isn't the surface. The surface isn't a flat layer. If this was a still lake, this is kind of what we'd look at right now, but the lake isn't still. So what we're going to do is we're going to take this vec2 out. We're going to say vec2. What is the surface of this? For now, it's going to be vec2, 0.2, 0.2, and we'll do a semicolon, and we'll replace this thing here with the surface. So this is the same thing as before, we're just taking things out. Now what I'm going to use to actually kind of get this surface wave is something called noise. And what we're going to do is I can just quickly type in GLSL FBM. We're going to use this technique called fractal or fractional Brownian motion. So this is some code that we're going to copy and paste. So I'm going to use this code from GitHub. I'm going to go to the 2D one and basically go to the raw one. And I'm going to take pretty much all of this code, maybe except this last line. Don't need that last line in there. So I'm just going to go up here and paste this code in. Now what I can do is use this FBM to move this surface around. So in my surface area, I don't need to do anything up here. My surface area is going to have some noise to it. So instead of this 2, I'm going to just put these on different lines to make it a little bit easier to read. There we go. So this first one I'm going to replace with this FBM. FBM. And in round brackets, we're going to say what 2 things we want to pass in. Well, the 2 things are where this is located, the UV. And as soon as we do that, we can see some movement start to happen. We can see this starting to shift around. Now I can also do this on the Y direction as well. So instead of this 2.0, sorry, 0.2, I always get those mixed up. I don't know why. So FBM UV, we'll see this effect starting to come into place very, very quickly. Now what I can also do on this FBM is add things like time to it. So I can add some time. And we're starting to get this water effect. Add some time in this direction, and we get some water effect here as well. Now, if I feel like this is too quick or there's too many waves, I can start to change some of these values. So for instance, if the time is too quick, I can say this is 0.5 times time, slowing it down here, 0.5 times time, so it's half the speed. I can also add more waves in here as well. So I could say this first bit is 5.0 times this, we'll get this wave effect, and 5.0 here. So I'm starting to get this wave effect going on. Now, what you might notice is this always shifts over to the right and down. And the reason for that is FBM is always going to give us a number between 0 and 1. And if it's some kind of noise, it's always going to be generally in the middle at 0.5. So I want this middle point to not be at 0.5, but at 0 itself. So if I'm looking, generally what I want is a flat surface apart from these ripples. So around this, what I'm going to add is a mix. And here I'm going to say minus 0.3 to 0.3. And around here, I'm going to put brackets. So essentially what we're doing here is we're taking a 0 to 1 value and then making it go between minus 0.3 and plus 0.3. So basically it's shifting around into the middle instead. And I'm going to do the same thing in the other direction, the Y direction, minus 0.3, plus 0.3, comma this, and a bracket at the end. So what we're going to get is this shift now, and this is really based on actual water. We're using the correct refractive index here. Now, one thing you might notice on the final one is we have this kind of surface going down the page. So essentially what I want to do is make the surface at the top much flatter than it would be at the bottom. So I'm not getting this water effect in full. So to do this, I can actually just do some calculations. Above here, what I could say is a new value called float. And this could be some kind of strength value. Now, if I want to basically soften this a lot, I could say this is 0.5. And what I could do is take the surface and then times it by the strength. So before here, I could say strength times this. And you can see if I go down to 0, it's flat. 0.1, it's a little bit, 0.2, 0.3, 0.4. This could be 4.4 and it's fairly strong. But what I want to do is make this value change between where I am in the coordinate system. So what I could do is some kind of step here. Now, a quick way to do this and a quick way to show this is something like step, and in round brackets, 0.5, and then comma, uv.y. So here what we've got is a step. So above 0.5, we're not getting any surface strength at all. We're getting this flat one. But at the bottom here, we're getting exactly 1. So there's a split between this, and this is halfway across. I can change this value to be different ones. And you can see the step kind of moving up and down if I need to. But what I want to do is make this smooth. So beyond step, there's also a smooth step. So here, I'm going to say smooth step. I need 2 values, 0.5, 2. Let's do it to the bottom, 1. So here, I'm basically starting at 0 strength, 0, 0, 0. Halfway down, I'm saying, cool, let's start to add some strength now. And as I go down to the bottom, I'm at full strength. I can change some of these values as well. So maybe I want to make this a little bit tighter. So this could be 0.8 instead. So we get this wave effect. So now what I have is this kind of wave effect. I can start playing around with some of the numbers to get what I need. But how do we make this go onto the web? So what we'll do next is talk about how we take this code from here and add it to a website. So in the SuperEye editor, I've just quickly set up a project. Now in my index.html, I have a canvas tag. I've given this a width and a height of 1200, basically the size of the image. And what I've done in my style sheet is basically I've kind of moved this into the middle. I've made my body have a minimum height of the height of the browser with some display flex, line items in the center. And basically I've got my canvas having a max width, my max height, and a border around it so I can see it in red. Basically, this just makes it responsive and moves it into the center of the page. So I haven't really done much to actually set up this page. Just one canvas tag, a little bit of styling, and I've uploaded an image. So what I want to do is, how do I get this thing that I've made in KodeLife into my actual thing here? So what we want to do is take our GLSL code, which is the shader code that we've written, and put it in a canvas tag. Now, luckily, if we Google GLSL canvas, the top result is this great library called GLSL canvas. And what we can use here is some JavaScript to do this. So there's different ways to do this. Now I want to load this line here. So I'm going to take this first line of code and I'm going to copy it into my HTML. There we go. Now underneath, I want to add some of my own script because I need to know what code I'm adding at which point to which canvas. So underneath, I'm going to make a new script here, canvas.js. And in this, currently blank, I'm just going to add it to my index.html. So another script tag in here with the source of canvas.js. So how do I use this library? So again, there's a few ways we can do this. There's an easy way, which I actually don't like. I actually prefer the JavaScript way. So here it says create a canvas element and construct this sandbox from it. Now we've already got a canvas tag, so we're actually going to do slightly different than what we have here. So how do we do this? Back in my code, in my canvas.js, I'm going to say a constant of canvas. This is equal to a canvas tag. So I'm going to say in my document, I want to find a query selector. And what do I want to select? The canvas tag. So this red area here. The next thing I want to do is convert it into a sandbox using GLSL canvas. So underneath here, I'm going to say constant sandbox. This is going to be equal to a new GLSL canvas. Now watch out for the capitalization here. It's G and a C in the canvas, both capitalized. Now what I want to pass in here is that canvas tag, canvas. So I'm basically taking this canvas tag and putting it into GLSL. So what I can do is make something with it. Now here, how do we actually load it? So it looks fairly complex, but we'll talk about it piece by piece. Now what I can do is load it in using a string. So what I'm going to do here is a constant frag. Now what I've got here is a fragment shader. Now I'm going to do this with an equals and some backticks. Now the reason I'm using this backtick is this is a string which can have multiple lines. So I can actually go into multiple lines here and add lots of code. So just for now, I'm just going to add a little bit of code to make sure that this actually works. I'm going to add void main round brackets curly brackets. I'm going to open up the curly brackets. And inside here, I'm going to say GL underscore frag with capital F color is equal to vec4 round brackets 1, 0, 0, and 1, and a semicolon at the end. Now this is some shader code that I've just written from scratch. It's basically going to say this whole thing should be a red area. Now what we've done in the past is we've written our own shader code in KodeLife. We'll come to add this in. Now how do we get this fragment shader into our sandbox? Well, we load it in, sandbox.load. So here underneath, we're going to say sandbox load. What do we want to load? This fragment. So this now is in red. Now if I change some of these numbers here, we'll see this is in different values. Basically what we want to do next is take our code from KodeLife and put it in here. So what we're going to do is go back to KodeLife, and I'm just going to open up my project, open it up from recent, and I'm going to take all of this code, I'm going to copy it into the browser. So in my string, watch out for your backticks, we need them. I'm going to take this out and replace it with all of this stuff. Now the first thing you might notice is this may go black. Now there's two reasons for this. One, we haven't loaded in the image. So previously in KodeLife we pulled in this image. We're not doing this currently in the browser. So to do this further down, we can say sandbox set uniform. We can pull it in as a string. So underneath sandbox.load, sandbox.set uniform. What do we want to pass in? Well, we called it image. And where does the image live? In jellyfish.jpg. Now what you might notice here is we see the image, but it's not moving. And there is a reason for this. And the reason is that KodeLife and GLSL canvas work slightly different. So here in KodeLife, we have this thing called time, but in our GLSL, it's called u_time. So we just need to update our code to match this new format. So what we're going to do is we're going to find the bits in here that say time. We're going to change it to u_time. So here, and we're going to find the next one, which is in void and main. We're using it here, u_time and u_time. And as soon as we do this, we'll get this texture moving in the browser. So what we can start to do now is change how this looks. We can start to play around with this. And there's a lot more things we can actually do. We can make this move on mouse movement. We can make it move based on interaction layers as well. We're going to keep it nice and simple. The only thing I'm going to do is remove this border for now. And what we have is this wave effect in the browser using GLSL.